Okay, we got answers here for homework number 8. Let's go through them quickly. You can pause it as you need to. That's through 19. That takes you through number 28. And that finishes it off. All right, once you've graded it, I'm going to do the explanations for all of them. Here we go. All right, so remember, a negative exponent means either take the reciprocal, that would be take the reciprocal. The reciprocal of x is 1 over x. That turns the exponent positive. And then a negative exponent that is in a fraction means take that term that's got the negative exponent and move it to the opposite spot in the fraction. And that's the same as taking the reciprocal. Right? I will be using those two things the entire time. Here we go. The first problem, since it's not a fraction, I like to make it a fraction by putting it over 1. And then I take the term that's got a negative exponent and I move it to the opposite spot in the fraction. That gives me b to the third over a squared. I have turned the exponent positive. There's nothing else to simplify. I'm done. Number 2, I need to take this thing that's got a negative exponent and move it to the bottom. That gives me all 7 c's on the bottom. The c to the third, it's got a positive exponent. It stays on the bottom. The only thing left on top is the coefficient of c to the negative fourth, which is a 1. So I end up with 1 over c to the 7th. Number 3. The a's that are on the bottom need to move to the top. So that gives me 8 a's that were already on top and 2 more a's that are moving up there, a total of 10 a's on top. Now let's look at the b's. The b's have 4 on top and 1 on the bottom, right? So that's like 4 b's on top, 1 b on the bottom. You cancel out anything they have in common. That leaves me with 3 b's on top still. And the only thing left on the bottom is the original coefficient of 1. And of course, we know a better way to write that answer. When everything is over 1, you don't need the 1. Number 4. In number 4, these a's on the bottom need to move to the top. Now there were already 4 a's on top, plus 1 more moving there gives you 5 a's on top. I'm done with the a's. Let's look at the b's. The b's have a negative 3 on top, which means they need to move to the bottom. And they're joining the 5 b's that are already down there. That gives you a total of 8 b's on the bottom. And there's nothing else to simplify. Number 5. Number 5, I need to take the r's that have a negative exponent on top and move them to the bottom. That gives you a total of 7 r's on the bottom, because the 2 that are on the bottom are going to stay there. And I need to take the 2 s's that are on top and move them to the bottom, because they have a negative exponent. So I need to take the reciprocal, which really just means move them to the opposite place in the fraction. That gives me 7 s's on the bottom. And the only thing left on top is the original coefficient. So I end up with 1 over r to the 7th, s to the 7th. All right, number 6, this thing is not a fraction, so I'm going to make it a fraction by putting it all over 1. The terms on top that have a negative exponent, they need to move to the bottom, and that will turn their exponents positive. And so my final result is the only thing left on top is the y to the fifth. The x moved to the bottom, which turned the exponent positive. And when the exponent is positive 1, I don't need to write it. The z's moved to the bottom, and they have an exponent now of positive 2. The negative 2 changed to a positive when you took the reciprocal. That brings me to number 7. Well, one way to do number 7 is to make it a fraction, and this thing on top that's got a negative exponent needs to move to the bottom. And that turns the exponent positive. So I really just have 1 over 3x to the second. Then that 2 needs applied to each thing in parentheses, giving me 1 over 3 to the second, which is 9, and x to the second. All right, 4 to the negative third. Here's one I'm not going to make a fraction because it's just a single term. I'm just going to do what negative exponents tell you to do, and that's take the reciprocal. I'm going to take the reciprocal of 4. And that turns the exponent positive. So I guess I could then simplify it. 4 to the third power means 4 times 4 times 4, which is 64. Number 9, I'm going to use the power to a power rule, where I multiply. When I have an exponent raised to an exponent, I multiply them together. That would be 3 to the positive 2, because negative 2 times negative 1 is positive 2. And then 3 to the second power is, of course, 9. Number 10. Well, the first thing I need to do in 10 is simplify the fraction 20 over 15. Both of those can be divided by 5. 20 divided by 5 is 4, and 15 divided by 5 is 3. Then we take a look at the variables. The a's that are on top have a negative exponent, so they need to come to the bottom and join the 3 a's that are already down there, giving me a total of 7 a's on the bottom. The b's that are on the bottom, they need to go up to the top and join the 3 b's that are already up there. And that gives me a total of 4 b's on top. Now the c's, these guys both need to switch places because they both have a negative exponent. So it's really c to the 10th on top when that guy moves, and c to the 7th on the bottom when that guy moves. And then when I cancel out the c's, 10 on top, 7 on the bottom, I cancel them out. There'd still be 3 left over on top, right? There's 3 extra on top. And that's my final result. All right, now we have a review of some old stuff. Number 11 is a multiplication problem. I'd multiply the coefficients and get 10. I'd add the exponents. Remember, this is y to the first and y to the first, which gives you y to the second. Number 12 is a multiplication problem. When I multiply the coefficients, but I add the exponents. 4x's and 3x's gives me a total of 7x's multiplied together. Number 13 is a multiplication problem. I would multiply the coefficients, giving me negative 12. But when I'm multiplying, I add the exponents. So this would be x to the 5th and x to the 1st, which is 6 total x's multiplied together. Number 14 is a multiplication problem. So I would multiply the coefficients and get 40, but I would add the exponents. I have 3 x's and another 1x, that is 4 x's. I have 5 y's and 2 more y's. That is 7 y's multiplied together. Number 15, I need to apply the exponent that's on the parenthesis to each thing in the parenthesis. That would be 4 to the second, x to the third to the second, and y to the second. And then when I use those exponents, 4 to the second is actually 16. X to the third to the second is x to the sixth because you've multiplied the exponents together. And y to the second is y to the second. 16 also needs the exponent on the parenthesis applied to each term in the parenthesis. That gives me 2 to the second, x to the second, and y to the fifth to the second. And then when I use the exponents, 2 to the second is 4, x squared is x squared, and y to the fifth to the second, an exponent to an exponent, you multiply them and get y to the 10th. Number 12 involves 2 skills. First, I need to take this and apply the exponent to each thing. So that would be 2 to the third, x to the third, and y to the third. And then when I actually use the exponent, this gives me 8, this gives me x to the ninth, and this is y to the third. But all of that was multiplied times 3xy to the fifth in the first place. So now I need to multiply those together. And when you multiply the coefficients. 8 times 3 is 24. And you add the exponents. Here I have 9x's, here I have 1x. Adding those together, that's 10 x's multiplied together. And here I have 3 y's and 5 y's. That's 8 y's multiplied together. Okay, number 18, I'm going to need to go ahead and multiply these terms and multiply these terms. So when you multiply the coefficients. 2 times 4, that's 8, but you add the exponents. 3 x's and 1x makes 4 x's. 1y and 1y makes 2 y's. Over here, I would multiply the coefficients and get 10. I have 1x and 3 x's. That gives me 4 x's. I have 1y and 1y, which gives me 2 y's. So when I get done multiplying, it turns out that these two terms are like terms because they have the same variables with the same exponents. So they can be added together, giving me something x to the fourth y squared, right? When I add like terms, I don't change the exponents. I just add the coefficients. 8 plus 10 gives me 18. X to the fourth, y to the second. Number 19, I need to first simplify the fraction, the coefficients. 4 over 6 can be reduced to 2/3. Both of those can be divided by 2. And then I just cancel out the variables, right? I've got 3 x's on top. I've got 1 x on the bottom. When I cancel out the x's, I have 2 extra x's on top. And for the y's, I have 1 y on top, 1 y on the bottom, right? And when I cancel those out, there's no y's left in the problem. So this is my final answer. Boy. So, here these have the same base, so I can just add the exponents. 5 3's and 10 3's all multiplied together would be 15 3's multiplied together. Here I need to, number 21, I need to reduce the fraction, 6 over 18. 6 over 18 can be reduced because both are divisible by 6. 6 goes into 6 once, 6 goes into 18 3 times. And then I need to cancel out the variables. With the x's, I have one x on top and 3 x's on the bottom. So when I go to cancel those out, there would be 2 x's left over on the bottom. With the y's, I have 5 y's on top. I have 2 y's on the bottom. So when I go to cancel those out, I end up with 3 y's left on top. And my final result is y to the third over 3x squared. Number 22, anything to the 0 power equals 1, so 17 to the 0 power is 1. Number 23, this whole thing is to the 0 power, and so the whole thing just equals 1. Number 24, I have a single term to a negative exponent, so I would take the reciprocal of 3, and taking the reciprocal is what turns the exponent positive. It'd be 1 over 3 to the second, which I could then simplify to 1/9. Again, when I have a single term to an exponent, or to a negative exponent, I just take the reciprocal of it. The reciprocal of y is 1 over y, and that turns the exponent positive. And that's really just my goal, is to turn the exponent positive. Number 26. Number 26, I would make it into a fraction, and then I would take the term that has a negative exponent and move it to the opposite spot in the fraction. So the a squared stays on top, but the b to the third moves to the bottom. Number 27, I would first simplify the fraction, 2 over 6. That simplifies to 1 over 3. Both of those can be divided by 2, right? 2 goes into 2 once, and 2 goes into 6 3 times. The variables, first I would deal with the m's. They have a -4 on the bottom, and that guy needs to move to the top, and he joins the 2 m's that are already up there, giving me a total of 6 m's on top. The n's have a negative on top, so that needs to move to the bottom and join the 2 n's that are already down there. I now have a total of 5 n's on the bottom. So there's my result. Number 28, I would probably first apply the 3 to each thing. That would give me 2 to the third power, x to the -5th to the third power, which gives me 8. 2 to the third power is 8, right? 2 times 2 times 2. And here I would apply the power to a power and get x to the -15th. But then I can't have a negative exponent in my answer, so I'm going to make this thing into a fraction by putting it over 1. And I'm going to take the part that has a negative exponent and move it to the bottom. So my final result would be the 8 stays on top, but the x to the 15th moved to the bottom. And finally, the last 6. In 29, I'm going to simplify 5 over 15. That reduces to 1 over 3. And now the variables. The x's. The x's both change places, right? So the x's end up with 5 on top and 2 on the bottom. Since they both have a negative exponent, they both have to take the reciprocal of both, which changes their spot in the fraction. And then you need to cancel them out. When you have 5 x's on top and 2 x's on the bottom, and you start canceling them out, you'll cancel out 2 of them and still have 3 of them left over on top. The y's. The y's have 5 on top, but this -1 needs to move to the top. So actually, all 6 y's end up on top, right? And the z's, the z's have 1 on top and 3 on the bottom. So when I go to cancel out the z's, there'll be 2 extra ones left on the bottom. And I'm done with that one. Number 30, there is no exponent property that works for number 30. You simply need to solve it using the correct order of operations, PEMDAS. You would first need to do this exponent, 5 to the second power. You would do this exponent, 3 to the second power is 9. And finally, you would multiply your results together. 9 times 25 is 225. All right, these last 4, an easy 4. When you multiply things together, you multiply the coefficients, but you add the exponents. X times x is x squared. When you add like terms together, you add the coefficients. The exponent does not change. When you subtract like terms, you subtract the coefficients. The exponent does not change. You end up with 1x, and a better way to write 1 times x is just x. And last up, when you're dividing, you can cancel anything out they have in common, so the x's cancel out, and 6 over 2 can be reduced to 3 over 1, or just 3. That's it.